All right, part two of the moon unit notes. Again, the moon does go in synchronous rotation, underlined, bolded in red. Could be a test question, fill in the blank. Yes, it's synchronized with Earth as its rotation is the same as its orbit. It's always facing us. We'll always see the Mare Imbrium, Mare Crisium, Mare Serenitatis, Mare Tranquillitatis. We'll see Tycho and the big crater Tycho. We'll see it all at the same time. We never see the backside unless we're out in a space mission. Look at the backside, which does not have as many Mari, by the way, because the Earth's gravity pulls the lava, the magma rather, our way. So when it gets crushed by a big meteorite, the lava easily pulls this way. But on the backside, it gets crushed. Not much seeps out. That's why you have very few Mari on the backside of the moon. So the moon does orbit from the west to the east, just like our Earth does. However, we see it rise in the east because our Earth also rotates from the west to the east. So since we're going faster west-east, that's once every 24 hours, than the moon does around us, which is once every 27.3 days. Therefore, it appears as the moon rises, just like the sun rises in our east, because we're rotating west to east. Good to know. Take that in class. Apogee and perigee. Apogee, A away, geo, Earth. So the moon at its furthest point from Earth is called apogee. Good term to know if you haven't already learned it. Is 406,731 kilometers from the Earth. At perigee, it is 364,397, almost a phone number. Yeah, it's closer to Earth. Here's the kicker. It does look a tiny bit bigger. That's why when we get in perigee in late autumn and winter, the moon's actually closer to us, and those full moons look bigger because they are a little bit bigger because they're a little closer. Now, you're thinking, wow, that's a long distance. In reality, if you drew the orbit, it's not that eccentric. It almost looks circular. So the average distance the moon is about 386,000 kilometers from Earth. So that's a long ways away. But the moon is actually closer to us. Wait, never mind. I'm getting the Earth. Earth's closer to the sun in the winter. The moon, it goes around us once a month, so it gets closer with every month and further once a month. All right, so yeah, the moon does look bigger at perigee when it's closer. Know the phases of the moon. You wax on and get brighter, and that always happens from the right to the left, like the diagram up in the top left. It gets dark and then it waxes. So here we go, full moon, waning, waning crescent, new moon, waning crescent, waning quarter, waning half. So the same diagram to the right shows you got a waning crescent, you got your waning quarter moon, you got your waning gibbous, which is gibbous means almost full, and then your full moon, and then your waxing gibbous, which means it's or waning, sorry, waning. Waning means to diminish, like if you have waning health, you're getting sick. So waning gibbous to waning quarter to waning crescent back to new moon. No matter how hard you try, you can't see the new moon because it's between us and the sun. The waxing crescent to waning crescent. If you don't know these, hey, you get practice in class. We're going to label stuff in class on a worksheet, so good practice. Why don't we experience a lunar and solar eclipse at every new moon and full moon respectively? Like at every new moon, why doesn't the moon block out the sun? And at the full moon, why doesn't the Earth block out the sun's light and give us the super blood moon like shown down below on the right? It's because the moon orbits the Earth at slightly different plane, just a slight different plane. So only twice when that plane crosses the same plane as the Earth going around the sun do we get eclipses. Here's a diagram showing the moon's orbit in yellow and the Earth's orbit in blue around the sun. And you can see the 2 points where they intersect. That's where eclipses would occur. Where they don't intersect, the moon, like on the right, the moon is too low to block out. But in front of us here on the left, it shows a good eclipse. All right, a solar eclipse is when the sun is eclipsed by the moon. That means we can't see the sun. The umbra is the total shadow, like an umbrella, total shadow caused by the moon. Penumbra is a partial shadow, which means it gets a little darker, but you can still see. That's because the sun's light is still coming around the moon. Again, these words are bolded and underlined. Good to know. So a lunar eclipse is when the Earth blocks out the bulk of the light from the sun, because an Earth has an atmosphere, and from the moon, the Earth and the sun are roughly the same size. Kind of like from the Earth, the moon and the sun are roughly the same size. Just the moon's a lot closer. But so they can, when the disk totally covers up, it doesn't totally cover it up because there's still light coming from our atmosphere being bent, and the red light then gets bent more and hits the sun and gives us that reddish full moon, where the sun's light hits the moon from the Earth's atmosphere, as described up in all the writing above here. So the sun's diameter, again, I just said this, is 400 times bigger than the moon, yet the moon is 400 times closer to the Earth. Therefore, they appear to be the same disk size. Amazing. We're all set in this perfect spot together with the right sizes that one will block out the other perfectly. So solar eclipse, time-lapse video, or not video, photo, and you can see the sun's getting darker, darker, darker. All of a sudden, when the moon blocks out the photosphere, the yellow part of the sun, now you can see the corona, which they call the diamond ring or whatever, the bright white pearly haze around the outside of the sun you usually can't see because it's not as bright as the photosphere, the yellow part we see. So the moonrise is an apparent motion due to the Earth rotating. Why does the moon appear to rise 13 degrees less each night? That means each night the moon appears, if you track it from night to night to night, it's moving east. Well, I just told you that earlier, because the moon rotates from the west to the east around us. So every day when we turn 24 hours, that moon's going to be a little further to our east because it is orbiting us from west to east. There we go. The moon orbits in the same direction that we do, from west to east. Our moon compared in size to our Earth and Neptune's moon Triton. Triton's a big moon on Neptune, but look, it's about the same size as our moon. All right. Everything else we're going to learn about in class. Marvin the Martian says, study for the moon test. Study the notes. Study your homework. Or classwork, I guess it is. Now it's flipped. And study your questionnaire, your moon activity, and you'll do well on this test. Have fun with it. That's all of part 2 and all the moon notes.